Alright guys, in this video we're going to learn how to solve quadratic equations using the square root method. There ultimately is 4 ways to solve a quadratic equation. You guys have learned the first method, which is factoring. And whenever you see a quadratic and you notice that it's factorable, that is always the most efficient way to use it. But here we can also use square roots when there is only one x term. Okay. So all that we see is x squared. There is no term with x in it. Just x. Okay, so some things to remember when using the square root method. When we solve a quadratic equation, we are looking for the x-intercepts of the function. We use this method when there is only one term with x in it. The square root method uses the reverse order of operations and inverse operations to solve quadratic equations for x. Every positive number has 2 square roots, a positive one and a negative one. And every negative number has no square roots. Alright, so let's check it out. We're going to solve these quadratic equations for x. Reverse order of operations has its own acronym, SADMAP. Remember that the order of operations, we use PEMDAS to remember it. Well, when we're solving equations, we use the reverse. SADMAP. PEMDAS backwards. Okay? So, you guys have been solving equations like this for years, since elementary school. We're going to use inverse operations. So I draw my dividing line. Oh, x squared. Wait a minute, that has an exponent. Here. To undo squaring, we use square root. So x squared has the inverse operation of square root. Okay? So to cancel out the square, I need to take the square root. I know that the square root of 25 is 5, but if there was a number that I didn't know the square root of, I can hit the second button and x squared, and that'll give me the square root symbol. And when I type 25 into the calculator, I end up with 5. So I know that x equals 5. But I did just previously say that every positive number has 2 square roots. But the calculator only gave you 1. And the calculator is only ever going to give you 1. Remember that squaring means that you take a number and you multiply it by itself. So 5 times 5 is 25. But negative 5 times negative 5 is also positive 25. So this equation, whenever you take the square root, you're going to end up with 2 solutions. I've got x equals 5, but I also have x equals negative 5. So the quadratic equation x squared equals 25 has 2 x-intercepts, one at positive 5 and one at negative 5. So let's try letter B. In letter B, I have a little more going on with x. That invisible number that is multiplying x squared is negative 1. And if I look at my reverse order of operations, multiplication gets undone before exponents. So I'm going to divide both sides by negative 1. And I end up with x squared equals negative 36. Oh, well that means x equals 6. Because 6 times 6 is 36. Let's just check to make sure. I hit the second button and x squared to get my square root symbol. And then I'm going to type in negative 36. Uh-oh, I got an error message. Non-real ands quit go to. What the heck does that mean? There is no number on the number system that we know that I can multiply by itself to make a negative. Because a positive times a positive is a positive. But so is a negative times a negative. A positive. So there is nothing that I can multiply by itself to make a negative number. So the moment that you see that you're going to take the square root of a negative number, you can stop. There are no real solutions. All right. All right, so I want to solve this quadratic for x. I'm going to draw my dividing line. And I go to take the square root of each side. And when I put that in the calculator, I get a really long decimal. So I need to see if I can break this 96 down a little bit, because the appropriate way to write your solution is to simplify your radicals. This is a radical. So I'm going to see if I can take out any perfect squares out of 96. So what are my perfect squares? 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16, and so on and so forth. So I'm going to start by seeing if I can divide 96 by 4. 96 divided by 4 gives me 24. Okay, so I know that 96 is 4 times 24. But 24 is also divisible by 4. So I can rewrite this as the square root of 4 times 4 times 6. All right, what about 6? 6 is divisible by 1. 6 is divisible by 2. But 2 is not a perfect square. And neither is 3. So I've got 2 perfect squares times 6. So I can rewrite this as the square root of 4 times the square root of 4 times the square root of 6. Because I know that the square root of 4 is 2. But the square root of 6 can't be broken down anymore. So when I take the square root, I actually end up with x equals 4 times the square root of 6. But remember, I took the square root of a positive number, so x also equals negative 4 times the square root of 6. Okay? Little more complicated, but it's going to be okay. This business of breaking down your square roots is incredibly useful and helpful when you move on to Algebra 2 and geometry and pre-calc and calculus and whatever other math you might end up studying. Okay, so in example number 3, we've got a little more going on. I'm going to bring out my SAD map. And I'm going to draw my dividing line. And I look, do I have any addition or subtraction in my math problem? And I do, so I'm going to add 6 to both sides. And I end up with 4x squared equals 80. So I've taken care of the addition and subtraction. Do I have any multiplication or division? And the answer is yes. So I'm going to undo the multiplying by 4 by dividing by 4. And I end up with x squared equals, it's not 40. X squared equals 20. So now all I'm left with is my exponent, so I'm going to take the square root of both sides. So I end up with x equals. Now is 24 divisible by any perfect squares? We know it's divisible by 1, but is it divisible by 4? And the answer is yes. So I can rewrite this as the square root of 4 times 5. And 5 doesn't have anything that goes into it except for 1 and 5. So we're done breaking this down. I can rewrite this as the square root of 4 times the square root of 5. And I know that the square root of 4 is 2. So square root of 20 breaks down into 2 root 5. So I know that x equals 2 times the square root of 5. But x also equals negative 2 times the square root of 5. And here is where my x-intercepts would be. Hopefully you guys are doing okay. We've only got 2 more to go. Whew, this one's a little more complicated. I'm going to draw my dividing line. I'm going to write my SAD map down. Make sure I don't miss anything. And I look to see if I have any addition or subtraction outside of the parentheses, and I do. I've got this positive 8 that I'm going to move to the other side with subtraction. So I end up with 9 times 2m minus 3 squared equals 441. I also have some multiplication, so I'm going to undo that multiplication with division. I have no idea what 441 divided by 9 is. Hopefully it's not something crazy. So I'm going to do 441 divided by 9, and I end up with 49. All right, 49, I like 49. So I have 2m minus 3 squared equals 49. Exponents comes before parentheses. So at this point right here, we're going to have to take the square root of both sides. And the moment you go to take the square root, your equation splits into 2 equations, kind of like it did in factoring once we found our factors. So I've got 2m minus 3 equals the square root of 49, which is 7. But the other square root of 49 is negative 7. So I have to set 2m minus 3 equal to negative 7 also. And now I'm ready to solve 2 linear 2-step equations. I'm going to add 3 to both sides. And if you want, you can solve them simultaneously. I'm also going to add 3 to both sides on my other one. Negative 7 plus 3 is negative 4. And then I divide by 2. And I end up with m equals 5. Divide by 2. And m equals negative 2. So this quadratic looked super complicated, but it's got 2 nice, easy, whole integer intercepts. One at 5 and one at negative 2. All right, last one. All the marbles. I'm going to draw my dividing line. I write my SAD map. I've got a minus 5, so I need to add 5 to both sides. Now I can divide both sides by 4. And when I divide both sides by 4, I end up with 57. And then I'm going to take the square root of both sides. So right here, my quadratic is going to split into two pieces. Six x minus 1 equals the square root of 57. And 6x minus 1 equals the negative square root of 57. Now, a couple of weeks ago when we started factoring and we were working with perfect squares and finding numbers that multiply and add and divide to make other numbers, I mentioned the divisibility rules. My favorite divisibility rule is that if you have a number, you can add its digits together, and if when you do, that number is divisible by 3, then the number is also divisible by 3. But I don't know how many times 3 goes into 57. 57 divided by 3 is 19. So I can break this down into 3 and 19. But 3 is prime, and so is 19. Since I don't have any perfect squares that divide into 57, I can leave it as is. So I've got 6x minus 1 equals the square root of 57, and 6x minus 1 equals the negative square root of 57. And I'm ready to solve. I'm going to add 1 to both sides. But now that square root is kind of treated like a variable, we cannot say that the square root of 57 plus 1 is the square root of 58, because it's not. So we keep those separate. And then I divide both sides by 6. So x equals the positive square root of 57 plus 1, all divided by 6. And x equals the negative square root of 57 plus 1, all divided by 6. And you're done. Those are your x-intercepts. That's about as complicated as it's going to get for solving quadratics with square roots. So to recap, you solve a quadratic using the square root method when you only have one x term. Okay? Remember that a positive square root has two solutions, a positive one and a negative one, and a negative square root has no solutions. Use inverse operations and reverse order of operations to solve your quadratic the same way you've been solving equations since elementary school. Go ahead and give the following 3 problems a try on your own. Make sure to get your answers checked before moving on to part 2.